Elementary, we are wrapping up our algebra unit with the Bowser of all objectives. It brings back several. Last week we talked about PO48, 51, 52, 59. There's a lot of algebra involved in solving radical equations. And we started with extraneous solutions. An extraneous solution is a calculated, if you don't have the definition, a calculated solution that, if I can spell that correctly, calculated solution that doesn't work in the original equation. Which is why it is so important that you check your answers with radical equations, because you do all the math right, you do the opposite operations, you square, you factor, you quadratic formula, you do all that stuff, and it turns out that one of the answers isn't actually right. Okay. Not because you did any sort of math wrong. Sam, can you put that back in the bin, please? Not because you didn't do any math wrong, but because it doesn't actually work. Okay? So, let's start with the one that we had on the homework check. I think we've done this one together already. Yeah. But just for people that were gone, or you can check to make sure you have all of the steps. Not everyone got the point for this one on the homework check, so we can just start off with this. What do we do first? Boolean. What are we doing first? Subtract the 2. Okay.
Why do you want to subtract?
Our first goal is to get the radical term by itself. Right? The 2 and the x are locked inside that root, boys, and we have to undo the root, okay, before we can go any further solving for x. But any equation that you've ever had, you usually start with that constant, move it over, and that's what we are doing here. Yes? Yeah, what comes next, Nick?
Then you gotta square the root in the 4.
Right. Because you are PERMDAS people, right? What undoes a radical? A power. Okay? What undoes a square root is square it. Nathan, Gavin, I don't want to have to stop for the 2 of you again. You'll be out in the hallway. You'll be at the office. Okay? This is go time right now.
Lock in.
Okay? Lock in. Thank you. So you cancel out the radical. You cancel out the power. And what you're left with then is 2x. That doesn't change because all you're doing is undoing the operation. You're canceling out the operation. And then the right side does change. It becomes a 16.
That's not good.
Finally, divide both sides by 2. And whoopsie-doo. 16 divided by 2 equals 8. Okay? Now, because this is radicals, we're going to take this solution, plug it back in, and we're going to say, does the square root of 2 times 8 plus 2 equals 6? Well, 2 times 8 is 16. The root of 16 is 4. And 4 plus 2 does equal 6. This checks out. Okay? You won't get an extraneous solution when you have just one answer here, but you should still check it in case you made a math mistake someplace else. Okay? But where you'll get the extraneous solution is when you have more than one answer, where you have to factor, use the quadratic formula. Okay? That's where you have that extraneous potential. So let's do one. Not the same one that we did on Thursday. Let's pick a different one. Which other one looks particularly tantalizing? Yes.
-2.
So the last one, second row.
Yeah.
Very good. All right. I do apologize. There's not a whole ton of space to do your work here. I think last year I made a mental note to spread this out, and I never did. You do have a backside though that's completely blank. And so if you want to write this on the top of the back page and do the work there, that's fine with me. So our goal initially, get the root by itself. What are we doing first? Goal.
We want to get the root by itself.
Yes, and how do we start that? What's our first step in the process?
-8.
Okay, subtract 8 from both sides. And that gives us -2 times the root of 3x minus 3 equals -24. Now what? Yeah.
Divide both sides by -2.
Yeah, divide both sides by -2. Remember, this just says -2 times the root of 3x minus 3. It'd be the same thing as said -2 times n. to get n by itself, you divide by -2. To get the root by itself, what you're multiplying -2 by, you're going to divide by -2. Okay? All it does is cancel it out. And so we have the root of 3x minus 3 divided by -2 over here. And thankfully, that makes it positive. What would happen if you had the root by itself with a negative value on the other side? To where, if you had something like 3x minus 3, if that was a positive 2 and it equaled -12, would that be an issue?
Yeah.
Why?
Because you can't find the square.
Because you're asking to get a negative value for a square root. Whatever x is, you plug it in there to get a negative value. That's not how roots work, except for the context of parabolas, because you have the 2x intercepts, right? Generally, a root's not going to give you a negative solution. So it is good news for us that we took a negative and divided by -2, and that gives a positive value over there. What next now? What happens next? Colin. We square. Once you isolate the root, don't touch anything inside of it, because the operation to undo is the root itself. Okay? You're not going to add 3. You're not going to do that. Take care of the root first. Square both sides to cancel out the root. And now you end up with a really pretty straightforward 2-step equation. 3x minus 3 equals 144. Okay. Nathan.
Can we do the first one in the second row?
Well, we're not done with this one yet, but yes,
Like
we can do that one
147.
next. Right? Now, add 3 to both sides. We get 3x equals 147. Divide both sides by 3. We get x equals 49. We can be confident it's not going to be extraneous because we only have one solution. The only thing that might come into play here is if you did the math wrong and you made an arithmetic mistake, and x isn't actually 49.
It isn't?
No, I'm saying it is 49. Okay, Nick, question.
I was just gonna ask you to give me another one.
Yes, Nathan asked for the first one here.
Can I get one after this?
So the first one, I'm going to have you do something by yourself because ultimately you need to do this solo, right? I can't do them all for you. We've now done 4 of the 9 on the page, so I think we'll stop
I'm
after
sorry,
5.
but I'm just confused on this one.
Yeah, so what would your first thought be here?
Add 1.
Add 1. You're absolutely right. Okay? We want to get the root by itself. So we're going to add 1 to both sides, and we get the root of 5 minus x equals x plus 1. Remember, as Nathan learned last Thursday, you can't actually add x and 1 because they're not like terms. Groundbreaking moment for you. It was like the highlight of my teaching career, that moment there when the light bulb suddenly kicked on, right? But it's not going to be 1x or anything. We can't combine them, so it's just x plus 1. And Nathan, is this where we got a little bit confused perhaps?
Yeah.
Okay?
Well, ask him to square it.
Okay, so our next step would be to square. And here's the kicker with this. What are we squaring on the right side? Caleb.
The x and the 1.
The quantity x plus 1. When we square both sides, we treat that right side as a binomial, right? As a binomial, which means, that just cancels out. That there's nothing to do there. That's cool. But on the right side, what do we get? Chase.
X squared plus 1.
Nope.
But it's x1 squared equals 1.
1 squared does equal 1. X squared does equal x squared. But
X squared.
what are we forgetting?
Oh, don't you're Oh.
You have to foil, craft law, or box this. Okay? You have to foil, craft plot, or box this. So you do the work, you ultimately get x squared plus 2x plus 1, which means what type of equation do we have here?
No, isn't it? Oh, no. That's 1 times.
What if we were to graph this x squared plus 2x plus 1, what is it going to look like on the coordinate plane? Parabola, right? And so when we go to solve for x, which is ultimately what we're trying to do here, what do we have to keep in mind knowing that it's a parabola? You could have 2 potential solutions. which means you could have an extraneous solution. Okay, so when you see that x squared there, that's the trigger in your mind that, oh boy, I'm gonna have to really pay attention closer. Anyway, in order to use this, we first have to set the right side or the left side equal to 0. So we're gonna subtract 5. Make sure you subtract 5 from the right term over on the right side there. It's gotta be the constant. We're gonna add x. Make sure you add x to the correct term on the right side. That cancels out everything over here.
So it's x squared.
And so we're left with 0 equals x squared plus 3x minus 4.
Is that the answer?
No. We're just getting started, Cole.
Oh boy. Mistakes.
Okay?
This isn't fun.
So, but now that we've got our quadratic equation, and now that we have one side equaling 0,
I don't know what to do.
what are our options to solve this?
Use multiple.
Caitlin?
You have the number puzzle, or you can do the quadratic formula.
You can either factor it, right, which is that what times what equals C, what plus what equals B, or you can use the quadratic formula. Factoring won't work every time because sometimes there isn't a solution to the number puzzle, even though there is a solution to the equation. So the quadratic formula works every time. Works every time. Okay? Can this be done with the number puzzle? Is there a solution?
Yes.
Something times something equals -4, and those same two numbers are +3. Is there a solution here?
Yeah.
What is it?
Is it positive 4 times -1?
+4
Am
and
I right?
-1.
How would you? Am I right?
Okay.
Am I right?
I'll do that one next. Okay. Yes, you are correct.
Oh.
Okay. So, because that's the solution to the number puzzle, now we set up our parentheses and we say x plus 4 and x minus 1. Remember, those numbers go into our parentheses. And because this whole equation equals 0, our values for x will be what makes each set of parentheses equal to 0. What makes x plus 4 equal to 0? -4.
That was the answer.
What makes x plus 1 equal to 0? +1.
That'd be the answer.
So here are our two possible answers. We've got to go all the way back up to the top and see if they actually work. Okay?
Positive 4 works.
If we plug in -4, Cole, it's not +4. We plug in -4, we get the root of 5 minus -4 minus 1 equals -4. Okay, we break this down a little bit. 5 minus -4 is the root of 9, which is 3. And does 3 minus 1 equal -4? No. Is -4 an extraneous solution then? Yes. If you include -4 on your test as an answer, will I mark it wrong? Yes. Okay. Now, just to make sure that we did the math right and something's got to work, right? If -4 doesn't, hopefully 1 does, otherwise we're back to the beginning again. If we plug in 1 here, and we say the square root of 5 minus 1 equals 1, that gives us the root of 4, which is 2. Does 2 minus 1 equal 1?
Yeah.
Whew. Okay, so we can say that x equals 1, that is the solution that works. -4 is the solution that doesn't work. Okay, Edward, do you have a question? What did happen to 3?
Wait, are we talking
This
about-
3?
Yes.
That just, I use that for the number puzzle.
Yeah.
The solutions to my puzzle are what go in my parentheses. This 3 just came from the equation
Oh,
there.
yeah. I was just wondering.
Eli,
If we find an extraneous solution, would be better to cross it out or erase it?
either one. Either one's fine. Nick,
How many extraneous equations are on, or extraneous solutions are on this page?
So
you have to
can't
assume
do
they
it.
all
So you can't do it.
No.
Then you cross it out.
are. You got a test.
So you just put an X on the code. Can you show me how to do the quadratic?
Drop one.
Cole,
Can we do another one?
no.
Oh, you
Kristen.
Why would you give us the option to do a version of it that only works like half the time?
Why am I giving you the option?
Yeah, it only works like half the time. So why would you?
Well, you always get the correct solution. It's just a question is the other one also correct? In anything that exists, there are, quirks. There are, I won't say inconsistencies. We'll stick with quirks. This is one of those things. Okay, and the reason why the quirk exists is because what a radical is. You can't have a negative solution to a radical. You can't take the square root of a negative number. Okay, and so that's where it kind of falls apart. I won't say falls apart. That's not very great. You need to check it. Okay, but it's not like there's this other method that you could use that doesn't give extraneous solutions. Then there's the Schultz method I'm showing you just because I want to make your lives complicated. That's not what's going on here. Nathan, yes, quadratic formula. So,
I already know it. Never mind.
oh, okay, very well. Anyone else want to see it?
Isn't it negative b plus or minus in the square root of
Yeah.
b squared minus 4ac
Well, here, I'll just clear up.
over 2a?
So, for the quadratic formula, we ended up with 0 equals x squared plus 3x minus 4. Remember that these equations are written in the form ax squared plus bx plus c, where a is the coefficient to x squared, b is the coefficient to x, and c is the coefficient to -4, or the constant. So when you go to the quadratic formula, which negative b plus or minus the root b squared minus 4ac over 2a, -3 plus or minus the root of 3 squared minus 4 times a, which is 1, times c, which is -4, all divided by 2 times 1. Right? And we talked about doing that b squared minus 4ac part first. The 3 squared minus 4 times 1 times -4. That gets us -3 plus or minus the root of 25 divided by 2. Okay? 3 squared minus 4 times 1 times -4 gives you positive 25, which we like, because what do we know about root 25?
It's a prime factor, whatever.
Perfect square.
That's what I meant to say.
Mr. Schultz,
Yeah.
do you go over all your steps again?
All I did was I solved this.
Well, yeah, but like, where'd you get x squared plus 3x minus 4?
We did that one in the first round. We did that after we added 1, squared both sides. This,
Oh,
folks, shh. Once you get to this step, Sam, this is where you can decide, do I number puzzle factor, do I use the formula? And so the first work, but you have to get here first, and so we did that in the first example. So now we have -3 plus or minus 5 over 2, which remember means you get one answer, -3 plus 5 divided by 2. Second answer, -3 minus 5 divided by 2, and you still get 1 and -4 from those. You do still need to check them both, okay? One might be extraneous, we already found out. This is the extraneous one, and this is the answer that works. Okay? All right. This is due tomorrow. You've got 5 of them left on the page. 5 we have not done. Obviously, work must be shown. You need to show me if there are any extraneous solutions. And I will be here to help. Mr. Link is here to help. You can work with a partner if you want.
I only have 3 left.
Great.
Same.
I don't know.
Nick,
Do you still believe that nerds rule the world?
I do.
I don't.
Yes, I do.
L.
Are there any questions on what the homework is tomorrow? Class, is PO64 homework due tomorrow?
Yes.
Yes, it is. That's how you math.
It's not.